Tonight, we set our sights on a destination beyond the familiar reaches of our solar system, a star that lies quietly in the darkness of our cosmic neighborhood. This star, Proxima Centauri, is the closest known star to our own Sun, at a distance of approximately 24 light-years. That means even if we could travel at the speed of light, the fastest possible pace in the universe, it would still take over 4 years for light to cross the space between our Sun and this tiny, distant companion. Proxima Centauri is a red dwarf, far smaller and cooler than our Sun. Its light is faint, a deep crimson glow barely visible without the aid of telescopes. Despite its modest size, Proxima Centauri is of great interest to astronomers, for it hosts at least one known planet, called Proxima b, which orbits within the star's so-called habitable zone. This means that, under the right conditions, liquid water could exist on its surface, a tantalizing hint of worlds beyond our own. From our vantage point on Earth, Proxima Centauri appears as a dim speck, almost lost among countless other stars. Yet this tiny red dwarf represents the nearest gateway to another solar system, a neighboring star that sparks the imagination and inspires the dreams of interstellar exploration. As we begin our journey, we leave behind the familiar orbits of our Sun's planets and head toward this distant, intriguing star, crossing the void of space in pursuit of discovery, curiosity, and the simple wonder of seeing another sun up close. We begin on the surface of Earth, our vibrant, living world suspended in the inky blackness of the solar system. Beneath us, oceans ripple and forests stretch across continents, clouds drift slowly in the atmosphere, and the familiar patterns of life continue uninterrupted. From this vantage point, it is easy to forget the vastness that lies beyond, the emptiness that stretches between our Sun and the stars that speckle the night sky. Tonight, however, we will venture beyond the confines of our home, leaving the comfort of Earth's gravity and stepping into the infinite expanse of space, heading toward our nearest stellar neighbor, Proxima Centauri, some 24 light-years away. From our perspective above the surface of Earth, the first moments of our journey are intimate yet profound. We are leaving behind the familiar, the living, breathing world where life has thrived for billions of years, a planet suspended in the delicate balance of the solar system. Earth rotates slowly beneath us, its continents and oceans drifting into view, a mosaic of colors that reflects the vitality of the biosphere. The atmosphere shimmers in subtle blues, scattering sunlight and creating the soft glow we recognize from every sunrise and sunset. From orbit, these patterns are amplified, and we begin to sense the scale of our home, its fragility, and the intricate forces that have shaped it. The Moon, our constant companion for over 4 billion years, comes into focus as we ascend. Though we have observed it from the surface countless times, its features become more apparent from above. Craters, scars from ancient collisions, stretch across its surface like a map of history. Mountains rise along its edges, remnants of geological upheavals, while smooth plains reveal lava flows frozen in time. The Moon is roughly 384,000 kilometers from Earth, which converts to about 0.00041 light-years. If we were traveling at the speed of light, this distance would be covered in less than 1.28 seconds, yet even in that fleeting interval, the view is majestic, a silent testament to the forces that have shaped our nearest celestial neighbor. From orbit, the Earth-Moon system appears as a delicate dance. The Moon orbits Earth at an average speed of about 1 kilometer per second, and while this motion seems slow on a cosmic scale, it is steady and unrelenting. We see the interplay of light and shadow across its surface, how the Sun illuminates the craters differently at each moment, emphasizing the stark contrast between its bright highlands and dark Maria. This is a world without atmosphere, and yet its history is written in the very rocks and dust that cover it, a frozen record of impacts, solar wind, and the slow passage of time. As we drift farther from the Earth-Moon system, we begin to sense the boundaries of what we once considered nearby. The moon, so prominent in our night sky, shrinks rapidly behind us, becoming a pale dot against the darkness. In this moment, the realization sets in. The distances between worlds are vast, even within our own solar system. The moon, though close in human terms, is a stepping stone in a much larger journey, a first milestone on the path to the stars. The moon's influence extends beyond its surface. Its gravitational pull has shaped Earth in subtle but profound ways. Tides rise and fall in response to its presence, regulating the rhythm of oceans and influencing climates. For billions of years, the moon has stabilized Earth's axial tilt, maintaining the consistency of seasons and enabling the evolution of life. From orbit, we see these effects indirectly, reflected in the distribution of water and land, in the patterns of clouds and storms, in the interplay of light across oceans and continents. The moon is more than a satellite. It is a guardian of life, a companion that has silently accompanied our planet through eons of change. As we move away, the Earth itself begins to transform in appearance. The atmosphere scatters light differently from this vantage point, and we can see the thin veil of gases that protects life from cosmic radiation, that moderates temperature, and that sustains the cycles of weather and climate. Earth rotates steadily beneath us, completing one full turn every 24 hours, and we begin to understand the scale of this rotation in relation to the vast distances we are about to travel. At the speed of light, even though we are covering these distances in moments, Earth continues its rotation, continuing its cycles, unaware of our departure yet intimately connected through gravity and shared history. From orbit, we notice the patterns of human activity. Cities glimmer faintly at night, the distribution of lights reflecting the concentration of populations and the infrastructure that has allowed civilization to thrive. Rivers and lakes reflect sunlight during the day, winding through landscapes shaped by both natural processes and human hands. Forests, deserts, mountains, all are visible from above, their textures highlighted by the play of light across the planet's surface. This view underscores the unity and fragility of life on Earth, the delicate balance that sustains ecosystems and civilizations alike. The Moon and Earth together form a system of motion and balance. The Moon's orbit, tilted slightly relative to Earth's equator, completes a cycle approximately every 27 1/3 days. From our departing perspective, we can track this motion, observing how its phases shift in relation to the Sun and Earth. This rhythm has guided human timekeeping for millennia, shaping calendars, cultural practices, and our understanding of celestial mechanics. It is a reminder that even as we leave, we are still bound by these natural patterns, by the dance of gravity and motion that governs planetary systems. Even in the moments immediately after departure, space feels vast and silent. The distances between Earth, Moon, and other nearby objects are so large that even traveling at light speed, it takes measurable time to cross them. The Moon, so near in the sky, disappears into the distance in seconds, yet it remains a point of reference, a marker of our passage from home into the broader cosmos. In this quiet, the mind begins to expand, slowly absorbing the scale and magnitude of what lies ahead. As we move farther from the Earth-Moon system, the view of our planet begins to shift. The blues of the oceans deepen, the greens and browns of landmasses blend into the swirling atmosphere, and clouds form patterns that change with the rotation of the Earth. At this stage, Earth is a jewel suspended in darkness, a reminder of life, of gravity, of the environment that shaped our evolution. Even as the Moon fades behind us, the connection remains. The system we leave behind is a dynamic, living network of forces, cycles, and history. Distance and time become more tangible in these moments. From Earth to the Moon, we have crossed 0.00041 light years, less than 2 seconds at light speed. Yet even this brief interval brings perspective. The Moon, close though it seems in our night sky, is a vast distance away in terms of travel. Each step in this early journey emphasizes the immensity of space, the scale that defines the universe beyond our immediate perception. The journey through Earth's orbit is also a passage through history. Satellites, space stations, and remnants of human exploration drift silently in orbit. They are the first artificial milestones in space, monuments to human curiosity and ingenuity. Even as we leave these objects behind, they mark the threshold between the familiar and the unknown, the transition from Earth-bound existence to interstellar exploration. Observing them from orbit, we see the reach of humanity extending outward, a first step toward the stars. As the moon becomes a tiny crescent in the distance and Earth a bright, fragile orb, the sense of scale grows. The interplay of light, gravity, and motion begins to dominate perception. The moon's orbit remains a constant reference, a gentle reminder of the balance that sustains planetary systems. Observing the system from this distance, it becomes clear that each celestial body is connected by forces that extend unseen yet unbroken across space. Gravity, light, and motion weave together the fabric of the solar system, and we are traveling within that fabric, part of its flow and its history. From orbit, the movement of the Earth-Moon system illustrates the harmony of celestial mechanics. The moon's influence on tides, rotation, and axial stability demonstrates the interplay of mass and motion over billions of years. Observing these effects from above allows a perspective unavailable from the surface, a broader awareness of how interconnected and delicate planetary systems are. Even in the first moments of departure, the cosmos begins to feel expansive, infinite, yet governed by principles that are both predictable and beautiful. The moon, a constant companion, now appears smaller with each passing second, yet its significance endures. Its surface, cratered and frozen in time, continues to record the history of impacts and cosmic events. It is a silent witness to the passage of eons, a testament to the forces that have shaped not only itself but Earth as well. In the quiet of space, the moon's presence offers reassurance, a connection to the home we have left behind, a reminder of the cycles and forces that govern the universe. As we glide beyond the orbit of the moon, we begin to see the first hints of the solar system's inner planets beyond our departure point. Mercury, Venus, and Mars are subtle points of light, markers of distances that, while vast, will one day be navigated by future explorers. The Moon and Earth, in contrast, remain close in memory, a point of reference and origin, grounding the journey in perspective and scale. Even as we leave orbit, the gravitational influence of Earth and Moon diminishes gradually. This transition is imperceptible in sensation but measurable in physics. The forces that once bound us begin to fade, replaced by the larger, slower influences of the Sun and the eventual pull of the Milky Way. In these moments, reflection becomes natural. The Moon, the Earth, the planets, the space stations, and satellites all form a tapestry of motion, light, and history, a context for understanding the greater universe beyond. Distance, time, and perspective dominate thought as we continue. From the Moon to the edge of Earth's orbit, the journey covers just fractions of a light year, yet in cosmic terms, it is the first step toward infinity. Each second, each kilometer, each rotation of Earth beneath us is part of a vast, interconnected system, and moving away allows a deeper appreciation of the scale and beauty of our home. At this stage, Earth begins to shrink in the field of view. Its features blur into a blend of blue, green, and white. The Moon, smaller still, orbits quietly, a companion in a silent dance. The solar system, once the entirety of known space, is now only a small segment of the vast expanse we are entering. The sense of motion is gentle, continuous, almost meditative, a perfect pace for reflection and the quiet wonder that accompanies the first steps toward interstellar travel. The journey from Earth to the Moon is brief in time at the speed of light, mere seconds, but rich in meaning. It represents the threshold of exploration, the first physical step away from home, and the point at which the universe begins to feel immense. The Moon, the Earth, and the space between form a bridge, linking the familiar with the unknown, grounding the mind while inspiring it to expand outward toward the stars. As we leave the comforting proximity of Earth and the Moon behind, the solar system unfolds before us in a slow, deliberate panorama. Mars, the red planet, comes into view, a world of subtle hues that hint at a complex and ancient history. From this vantage point, we can see the rust-colored plains and towering volcanoes that define its landscape. The light from Mars travels to us in mere minutes, a negligible fraction of the distance we will soon traverse, yet even this close encounter is filled with wonder. Mars is approximately 0.00015 light-years from Earth, or roughly 225 million kilometers at average distance, and if we were traveling at the speed of light, it would take only a few seconds for Earth to measure our passage. Mars is a planet of extremes. Its surface tells a story of water long gone, of riverbeds carved into the crust, of polar ice caps that wax and wane with the seasons. Olympus Mons, the tallest volcano in the solar system, rises over 21 kilometers above the surrounding plains, dwarfing anything found on Earth. Vast canyons stretch across its terrain, most famously Val Marineris, a system that would span continents on our home planet. From orbit, the scale is breathtaking. The patterns of erosion, sediment, and dust storms unfold as a testament to both geological forces and the subtle effects of wind and solar radiation over eons. Mars is also a planet of scientific intrigue. It has long been a target for exploration, from robotic rovers that crawl across its surface to orbiters that map its geology in exquisite detail. Evidence of past water, signs of seasonal methane release, and the possibility of subsurface ice hint at environments that might once have supported microbial life. Even in the brief moment of observation from our departing course, we can appreciate the complexity of this world, the echoes of planetary evolution, and the possibilities it holds for future human exploration. As we glide past Mars, we begin to feel the scale of the solar system more acutely. The vast spaces between planets, once invisible from the surface of Earth, become tangible. Distances that seemed abstract are now measured in light minutes, and even as the planets shrink in the field of view, their presence remains a reminder of the structure, order, and diversity of our immediate cosmic neighborhood. From this point, the journey toward Proxima Centauri becomes clearer. We are moving not just through space, but through the history and dynamics of the solar system itself. Jupiter, the largest planet in the solar system, comes into view next, a magnificent world of swirling clouds, massive storms, and vibrant coloration. Its size is staggering. More than 1,300 Earths could fit inside Jupiter, and its influence extends far beyond its visible atmosphere. The Great Red Spot, a storm larger than Earth, churns continuously, a dynamic and enduring feature that has persisted for centuries. Bands of clouds stretch across the planet, shaped by powerful winds and differential rotation, creating patterns of motion and color that seem almost painterly in their complexity. Jupiter is more than a visual marvel. It is a world that influences the entire solar system. Its massive gravity shapes the orbits of asteroids, comets, and even other planets. It acts as a cosmic shield, deflecting or capturing objects that might otherwise impact Earth. Its magnetosphere is the largest structure of its kind in the solar system, extending millions of kilometers into space and interacting with the solar wind in a continuous, complex dance. Observing Jupiter from our departing trajectory, we can appreciate not only its size and beauty, but its role in maintaining the delicate balance that allows the inner planets to exist as they do. The journey past Jupiter is also an opportunity to reflect on human achievement. Spacecraft such as Galileo, Juno, and the Voyager probes have provided detailed observations of this giant planet and its moons, revealing volcanic activity on Io, ice-covered oceans on Europa, and the intricate dance of the Galilean satellites. From orbit, we see the faint trails of these moons, orbiting in predictable harmony, each contributing to the complex gravitational ballet of the Jovian system. Even as we move at light speed, the time on Earth is only incrementally passing, measured in minutes to hours. Yet each moment contains a wealth of information and context about the solar system we leave behind. The distance to Jupiter from Earth varies depending on the relative positions of the planets, but on average, it is about 0.00082 light-years, or approximately 778 million kilometers. Traveling at the speed of light, only about 43 minutes pass on Earth as we cross this span. In human terms, it is almost instantaneous, yet in cosmic perspective, it represents a step deeper into the vastness that will soon dominate our journey. We leave behind the familiar inner planets, and the emptiness between the planets begins to expand, giving a foretaste of the interstellar distances that await. Jupiter's atmosphere offers a final spectacle before we move beyond the main planets of the solar system. High-altitude clouds drift along the planet's bands, ammonia crystals glint in the light of the sun, and storms of varying sizes ripple across its surface. Lightning flashes within the turbulent clouds, generating radio waves and illuminating portions of the atmosphere for brief moments. The scale of the planet is so immense that even at the closest approach, we are only skimming its outer layers, unable to penetrate the depths where pressures and temperatures rise beyond human comprehension. As we continue our trajectory beyond Jupiter, the gas giant recedes, its presence fading into the background. Yet its influence persists, a reminder of the forces that shape planetary systems. The moons, the rings, the magnetosphere, all continue their motions, unaffected by our departure, a silent ballet of gravity and momentum. Observing them from this vantage point, we gain a deeper appreciation for the intricacies of planetary mechanics, the interactions of mass, rotation, and energy that define worlds on scales both immense and subtle. Even as the planets pass behind us, we carry with us the lessons of the inner solar system. Mars teaches the fragility of life-bearing environments, the history recorded in rock, ice, and dust. Jupiter demonstrates the power of gravity and mass, the interplay of moons, storms, and magnetic fields. Each world serves as a waypoint on a journey that will soon leave planetary systems behind entirely, moving into the void between stars where distances are measured not in kilometers or light minutes, but in light years, and time passes on Earth in ways that remind us of the vastness of the cosmos. The journey through the solar system is both a visual and intellectual experience. The planets provide a sense of scale, illustrating the hierarchy of mass, distance, and influence that governs celestial bodies. They remind us that even the most enormous and dynamic worlds are but small components of a galaxy filled with billions of stars. Observing them, we begin to feel the transition from the familiar to the extraordinary, preparing our minds for the vast emptiness that lies ahead. Even at light speed, the passage from Earth past Mars and Jupiter allows only incremental moments on Earth, seconds, minutes, or hours, but the experience of crossing these distances is profound. We move through the solar system as silent observers, absorbing its scale, its dynamics, and its beauty. Each planet, each moon, each storm and canyon is a reminder of the processes that shape worlds, from internal geology to external forces, from the subtle pull of gravity to the immense energy of atmospheric motion. By the time Jupiter recedes behind us, the solar system has begun to shrink in perception. The inner planets are points of light, faint and distant, while the outer gas giants become smaller still. Saturn, Uranus, and Neptune lie ahead, subtle markers of the final reaches of the Sun's gravitational influence. The emptiness beyond these worlds begins to dominate the field of view, a silent expanse that stretches between stars. It is here, in this quiet space, that the true scale of our journey becomes evident, a prelude to the interstellar voyage that awaits. Distance, time, and perspective merge as we leave Mars and Jupiter behind. From Earth, we have now traveled a small fraction of a light year, yet each step brings a shift in understanding. The planets, once close companions in the night sky, are now distant points in a larger cosmic context. The mind begins to grasp the immensity of space, the vast separations that define the universe beyond our solar system, and the scale of the journey that will eventually bring us to Proxima Centauri, our nearest stellar neighbor. The journey past Mars and Jupiter is a meditation on scale and motion. It is a quiet, continuous passage that allows reflection on the forces that govern planetary systems and the beauty inherent in celestial mechanics. The vastness of space stretches outward, and yet the planets leave an indelible imprint on our consciousness, preparing us to enter the void between stars, where distances are measured in light years and time on Earth flows steadily forward. Each year a small marker in a voyage that will span decades in human terms but mere moments at light speed. As we continue outward from the orbit of Jupiter, the familiar planets gradually shrink in the distance, their presence fading into the darkness that surrounds us. Saturn, with its magnificent rings, drifts past, a delicate halo shimmering in the sunlight, followed by Uranus and Neptune, pale giants orbiting in near silence, their pale blue hues hinting at deep, hidden oceans and atmospheres of gas and ice. Each planet recedes, a fleeting memory of the solar system we leave behind, while the emptiness between them begins to dominate our perception. The space around us grows quieter, more still, and the sense of leaving home becomes tangible. The next threshold in our journey is the heliopause, the boundary where the influence of the sun's solar wind diminishes and merges with the interstellar medium. It is the edge of the sun's protective bubble, the frontier between the familiar warmth of our star and the cold, vast expanse of space beyond. Crossing this boundary is more than a simple matter of distance. It is a transition from the environment shaped by the sun to one defined by the galaxy itself. The heliopause lies at roughly 0.002 light-years from Earth, a distance of about 120 astronomical units. Traveling at the speed of light, just over a week passes on Earth as we glide past this threshold, though for us, the motion is continuous, smooth, and almost imperceptible in its progression. Voyager 1, humanity's pioneering spacecraft, serves as a silent marker for this crossing. Launched decades earlier, it now drifts beyond the heliopause, carrying with it the first intentional human artifacts designed for interstellar travel. Its golden record, inscribed with greetings, music, and images of life on Earth, is a testament to curiosity and imagination, an attempt to communicate across the void. Observing Voyager's path, we are reminded that even a tiny object, moving under its own momentum, can become a beacon of human achievement, a bridge between worlds and stars. The region immediately beyond the heliopause is filled with subtle cosmic activity. Interstellar space is not truly empty. It is permeated by tenuous clouds of gas, mostly hydrogen and helium, as well as dust particles carried across light years. Cosmic rays, high-energy particles accelerated by distant supernovae and other energetic phenomena, pass through the void in relentless waves. These particles are invisible yet detectable, moving across the galaxy at near light speeds, a quiet reminder that even in the seeming emptiness of space, the universe is dynamic, vibrant, and filled with energy. In this expanse, the stars become the primary markers of distance and direction. Unlike the solar system, where planets are relatively close together and motions are predictable, interstellar space is vast and largely empty. The nearest stars appear as faint points of light, isolated yet constant, their distances measured in light years rather than millions of kilometers. At 1 light year from Earth, 1 year has passed back home, and the scale of the journey begins to impress upon the mind. The emptiness is profound, and yet there is a sense of rhythm, a subtle structure revealed in the distribution of stars and clouds of interstellar matter. 2 light years from Earth, 2 years have passed on our planet during this voyage at light speed. The mind begins to adjust to the scale, perceiving space not as a void, but as a medium filled with faint, persistent energy. Stars that once seemed scattered randomly now form patterns in the sky, indicators of the spiral arms of the Milky Way and the broader structure of the galaxy. Interstellar dust drifts across the field of view, reflecting light from distant suns and creating subtle nebulae that glow faintly, hinting at regions where new stars may one day ignite. The journey beyond the heliopause also allows for reflection on the history and purpose of exploration. Voyager 1, now a silent traveler in interstellar space, demonstrates the human drive to reach beyond boundaries, to observe, to record, and to communicate. Its trajectory, carefully plotted decades ago, serves as a reminder that even in the vastness of space, intent, curiosity, and ingenuity can leave a lasting imprint. As we continue, we too are part of this continuum, moving outward, observing, and reflecting on the universe's scale, structure, and beauty. The emptiness of interstellar space encourages patience and contemplation. Unlike the solar system, where motion is apparent and distances can be measured in hours or days, here distances stretch across light years. Stars appear fixed, almost eternal in their positions, yet in reality, they move slowly relative to one another, their motions imperceptible without careful observation over centuries. The faint light of these distant suns reaches us after years of travel, a delayed connection across the galaxy, reminding us that time and space are intertwined in ways that challenge ordinary perception. At this stage, our speed, equal to that of light, allows us to cross enormous distances in what feels like a smooth, continuous journey. Yet even at this ultimate velocity, the concept of distance becomes almost incomprehensible. The first light year brings us 1 year forward on Earth, 2 light years, 2 years. Each interval is a quiet meditation on scale, a gentle unfolding of cosmic perspective. The solar system, once so immediate and familiar, is now only a memory, a reference point that anchors our understanding as we move into the deeper void. The interstellar medium, though sparse, is not entirely uniform. Variations in density, magnetic fields, and cosmic radiation create subtle patterns and effects. Over long periods, these patterns can influence the trajectories of objects, including spacecraft, and provide a medium through which light and particles interact. Observing these effects, we begin to appreciate the dynamic nature of space itself. Even in what seems to be emptiness, there is structure, complexity, and motion, a subtle energy that pervades the galaxy. As we glide further into this vastness, the stars of the Milky Way become clearer in their distribution. The spiral arms stretch across the void, dotted with clusters of young stars, glowing nebulae, and dense molecular clouds. These structures are faint but measurable, indicators of ongoing star formation and the processes that shape the galaxy. In this region, distances are vast, yet the coherence of the galaxy becomes apparent, a reminder that even the emptiness between stars is organized, patterned, and alive with subtle activity. Crossing the boundary of the solar system also emphasizes the relative brevity of planetary distances. The movement from Earth to the heliopause is measured in decades for spacecraft like Voyager 1, yet in light speed terms, it is almost instantaneous. Beyond the heliopause, the next reference points are stars themselves, and the emptiness between them stretches across light years. This shift from local to interstellar perspective is profound, inviting contemplation of scale, time, and the human capacity for exploration. In these quiet moments, as we glide past the edge of the sun's influence, we reflect on the first steps of humanity into space. The Moon, Mars, Jupiter, all have served as milestones, as laboratories, as windows into the processes that shape worlds. Beyond the solar system, these lessons continue to guide understanding. Gravity, radiation, motion, and energy operate consistently across the galaxy, and the principles observed close to home remain valid, even at distances measured in light years. The journey beyond the heliopause is also an opportunity to appreciate the subtle beauty of space. Cosmic rays, interstellar dust, faint magnetic fields, and the distant light of stars create a delicate, almost imperceptible tapestry. Observing this environment requires patience, instruments, and reflection. Yet it is as real as any planetary surface, as dynamic as any storm, and as profound as any landscape on Earth. The void is not empty. It is filled with motion, energy, and the history of the galaxy itself. As we approach 2 light years from Earth, 2 years have passed on our planet at light speed. The interstellar medium continues, largely uniform yet punctuated by distant stars, nebulae, and subtle density variations. The scale of distances becomes humbling. The nearest stars are now measurable as separate points of light in the vast expanse, each separated by years of travel even at light speed. The emptiness between them is profound, yet it is not hostile. It is quiet, serene, and full of potential. A medium through which future explorers will pass and through which light itself travels. The Voyager milestone serves as a reminder of what is possible when curiosity and ingenuity intersect. The spacecraft's path, determined decades ago, has led it into interstellar space, where it continues to transmit data back to Earth. Its journey is slow in human terms, yet rapid in cosmic terms, crossing boundaries and demonstrating the persistence of exploration. Observing it, we feel connected to both past and future, anchored by history while moving steadily forward. As we continue past the solar system, we enter a realm where distances are measured in light years, where time on Earth continues steadily, and where perspective shifts from local to galactic. The emptiness is profound, yet filled with subtle structures, magnetic fields, dust clouds, and faint radiation that tell stories of the galaxy's evolution. Each moment is an opportunity to reflect on scale, to meditate on motion, and to prepare for the journey that lies ahead toward Proxima Centauri, the closest star beyond our Sun. Beyond the boundaries of the Sun's influence, we enter a region of profound silence, a space almost entirely devoid of planets, moons, or other familiar celestial objects. This is interstellar space, the vast expanse that stretches between star systems, filled with subtle traces of matter, energy, and light that have traveled across unimaginable distances. The emptiness is overwhelming at first, yet in its quiet lies a slow, steady rhythm, a gentle continuity that encourages reflection on both the universe and our place within it. The first sensation of traveling through interstellar space is the realization of scale. Distances are no longer measured in millions or billions of kilometers, but in light years, the distance that light itself travels in a year. The stars that were once familiar points of light in the night sky become distant beacons, each separated by years of travel even at the speed of light. At 1 light year from Earth, 1 year has passed on our planet, though for us, moving at light speed, the journey is continuous and unbroken. We are moving through a void that feels eternal, yet even here, subtle structures begin to emerge. The interstellar medium, though nearly empty, is not without form or substance. Tiny clouds of hydrogen and helium drift through the darkness, remnants of stars long extinguished, or the raw material from which new stars will one day form. Fine dust particles float silently, reflecting the light of distant suns, and cosmic rays, high-energy particles accelerated by distant supernovae, pass through the void, invisible yet persistent. These elements, though sparse, are the threads that connect the galaxy, the medium through which light and energy propagate, linking one star system to another across unimaginable distances. At 2 light years from Earth, 2 years have passed back home, and the perspective deepens. The emptiness becomes a mirror, reflecting the vastness of the universe and the minuteness of our own origins. The sun, once dominant in the sky, has faded to a pinprick of light, dwarfed by the immense distances that now define our journey. Stars, distant and solitary, appear as faint points of color, white, blue, or red, each a sun with its own story, each possibly accompanied by planets we cannot yet see. This is a landscape defined not by proximity but by scale, where time and distance stretch the imagination and encourage a quiet, contemplative awareness. Interstellar space is also a region of gentle motion. Though the distances are vast, stars and gas clouds drift slowly relative to one another, moving in patterns determined by gravity, galactic rotation, and past collisions. The spiral arms of the Milky Way begin to reveal themselves in subtle ways. Clusters of young stars glow faintly, regions of active star formation pulse with energy, and molecular clouds drift silently, potential nurseries for future suns. Observing these features, we understand that even the emptiness is dynamic, that the galaxy itself is alive with processes unfolding over millions of years. As we travel deeper, the void begins to feel both immense and intimate. The nearest stars, such as those in the Alpha Centauri system, are visible in the distance, but their light is dim and slow to arrive. The perception of time becomes fluid, stretching across light years, while the mind adjusts to the sheer emptiness of the medium. Distances that were once unfathomable now take on a subtle tangibility. 3 light years from Earth, 3 years have passed at home, yet the journey continues as a steady, uninterrupted glide through the silent expanse. Subtle phenomena become more noticeable as the eyes adjust to interstellar darkness. The faint glow of distant nebulae, clouds of gas illuminated by the light of embedded stars, offers patches of color in an otherwise empty void. The distances span hundreds or thousands of light years, their light taking centuries to reach us. Even in this quiet, there is motion. Gas drifts, magnetic fields thread the clouds, and radiation moves outward from the stars that created them. These regions are reminders that interstellar space is not dead, but a slowly changing, intricate tapestry shaped by forces both visible and invisible. The journey is also a meditation on time itself. Traveling at the speed of light, each light year corresponds to a year passing on Earth. Yet here, in the stillness of interstellar space, time feels different, subjective, as the vast emptiness stretches our sense of distance and duration. The stars, the gas, and the dust are not simply objects to observe. They are markers of cosmic history, indicators of processes that span millions or billions of years. We move through both space and time, witnesses to the slow evolution of the galaxy, and participants in a journey that connects past, present, and future. As we approach the 3 light-year mark, the faint glow of the Alpha Centauri system becomes noticeable in the distance. These stars, though physically near in galactic terms, are separated from us by a gulf of emptiness almost impossible to comprehend. Their light is small, yet steady, a reminder that the universe is vast, but consistent, governed by predictable physical laws that allow even this immense journey to be charted, measured, and understood. The interstellar medium continues to shape the experience of travel. Fine hydrogen clouds absorb and scatter light, creating subtle shifts in color and brightness. Cosmic rays ripple through space, undetectable to the senses but measurable with instruments, reminders of the energetic processes that continue across the galaxy. Even in this quiet expanse, there is activity, a slow hum of energy and motion that defines the medium through which stars, planets, and eventually spacecraft pass. As we glide past the halfway point to Proxima Centauri, approximately 2 light years from Earth, we reflect on the scale of the universe and the nature of observation. Each distant star is a laboratory of physics, its light revealing temperature, composition, and motion. Molecular clouds hint at future stars and planets. Cosmic rays provide insights into violent events from across the galaxy. The emptiness is not empty. It is full of subtle stories, histories written in light, motion, and energy. The perspective from interstellar space allows a meditation on the human experience of scale. On Earth, distances are measured in meters, kilometers, or even hundreds of thousands of kilometers. In the solar system, distances expand to millions or billions of kilometers. Yet here, the measure is in light years, and the mind slowly grasps the immensity of space that separates even the nearest stars. The quiet encourages reflection, a slow awareness of our place in the universe, and a growing appreciation for the courage, curiosity, and ingenuity required to imagine such a journey. Passing beyond the halfway point, the Alpha Centauri system looms faintly, its light growing ever so slowly as the distance closes. Proxima Centauri, the smallest and closest of the three stars in the system, begins to glow as a tiny, persistent red point. It is a red dwarf, far cooler and dimmer than the Sun, yet a beacon for interstellar exploration. Its known planet, Proxima b, lies within the habitable zone, hinting at worlds that may host liquid water, and possibly, conditions conducive to life. Even from a distance of a few light years, its presence reminds us of the vastness yet intimacy of the nearest stellar neighborhood. The journey through interstellar space emphasizes both emptiness and connection. The distance traveled is immense, yet each light year provides information, observation, and context. The faint glow of stars, the motion of gas clouds, and the passage of cosmic rays all offer insights into the dynamics of the galaxy. Traveling at light speed, 4 years have passed on Earth by the time we reach the threshold of the Alpha Centauri system, yet the journey feels smooth, continuous, and meditative. Space itself becomes a companion, silent yet full of information, encouraging reflection on the scale of the universe and the nature of travel across it. In this vast expanse, we begin to perceive the delicate interplay of light, distance, and time. Every photon arriving from distant stars has traveled for years, carrying information about the environment from which it originated. Cosmic rays, though invisible, interact with magnetic fields and dust, creating subtle signatures of past supernovae or energetic phenomena. The emptiness is structured, patterned, and alive in ways that are imperceptible at first glance. It is a gentle, quiet universe, moving slowly yet with purpose, waiting to be observed and understood. As we approach the outer edge of the Alpha Centauri system, Proxima Centauri dominates the view. Its red light is soft, steady, and almost intimate compared to the vast emptiness we have crossed. From this vantage, the journey from Earth seems monumental, the distances traveled both humbling and awe-inspiring. The emptiness of interstellar space, once vast and daunting, now gives way to the first tangible presence of our destination, the nearest star beyond our Sun, a silent companion in the cosmic dark. Having traversed the vast emptiness beyond the solar system, we now approach the midpoint of our journey to Proxima Centauri, the moment where we are equidistant from Earth and our distant destination. This is a rare perspective in which the familiar and the unknown coexist in the same field of view. Behind us, the Sun is but a faint point of light, diminished to a small beacon that marks the origin of our voyage. Ahead, the red glow of Proxima Centauri is only beginning to assert itself in the darkness. The distance to Proxima Centauri is approximately 24 light years, and at the midpoint, we are roughly 12 light years from Earth and 12 light years from Proxima Centauri. For an observer remaining on Earth, just over 2 years have passed at this point, while for us, gliding at light speed, the journey feels continuous, smooth, and unbroken. Here, in this midpoint of the voyage, the mind begins to adjust fully to the immensity of interstellar distances and the concept of moving through a medium that is both vast and nearly imperceptible. Interstellar space at the midpoint is silent, yet far from empty. Fine clouds of hydrogen and helium drift across the void, remnants of ancient stars and the raw material for stars yet to be born. Interstellar dust particles, small as grains of sand, float through space, reflecting and absorbing faint starlight, creating a delicate diffuse glow across the darkness. Cosmic rays, traveling at near light speeds, continue to pass through this region, invisible to the eye yet measurable and persistent, a constant reminder of the energetic processes that ripple across the galaxy. At this halfway point, the stars surrounding us form a gentle tapestry. The nearest suns, Alpha Centauri A and B, appear as faint points in the distance, companion stars of Proxima Centauri, while more distant stars of the Milky Way sprinkle the void with subtle light. The distribution of these stars is neither uniform nor random. Their placement reflects the spiral structure of our galaxy, the gravitational interactions over millions of years, and the ongoing processes of star formation and evolution. Observing them at light speed, we realize that each photon we see has traveled for years, sometimes centuries, across the galaxy, connecting us to events and objects long past in human terms. The midpoint also allows reflection on motion and inertia. In this nearly empty region, there are no planets, moons, or spacecraft to provide immediate reference points. Yet subtle indicators exist. The apparent movement of distant stars due to our trajectory, the faint parallax shifts caused by our motion relative to the galactic background, and the occasional detection of interstellar dust or radiation. Even in the vast emptiness, there is a gentle structure, a rhythm to the cosmos that can be perceived by careful observation and patient reflection. Light and perspective shift subtly as we travel. Stars that appeared as points of light closer to Earth now seem more stable, their positions slowly changing in relation to one another. Proxima Centauri, though still distant, begins to stand out as a faint, persistent red point. Its light is steady, quiet, almost meditative, contrasting with the blackness around it. This midpoint gives a unique opportunity to see the journey as a continuous bridge between 2 points, Earth and Proxima Centauri, highlighting both the immense emptiness and the gentle, connecting threads of light that traverse it. Here, at 12 light-years from Earth, the passage of time on our planet has reached just over 2 years. Yet in the quiet of interstellar space, time feels different, extended, almost malleable. The absence of nearby celestial bodies allows contemplation of the immensity surrounding us. There are no familiar markers, no immediate horizons, only the slow accumulation of distance and the faint, distant stars that remind us of the broader galaxy. The midpoint is a pause of sorts, a place to reflect on both where we have come from and the still distant destination that awaits. Interstellar space at this point is also an environment shaped by subtle forces. Galactic magnetic fields thread the void, influencing the motion of charged particles. Cosmic rays continue their relentless passage, providing evidence of distant supernovae and energetic phenomena. The interstellar medium is tenuous but structured, with density variations that ripple across light years. Observing these patterns provides insight into the dynamics of our galaxy and the processes that govern the movement of matter and energy across immense distances. The midpoint is, in essence, a quiet threshold. Earth has faded to a small, cold point in the distance, the sun's light barely distinguishable among the stars. Ahead, Proxima Centauri is still tiny, yet its light serves as a guiding beacon, a reminder that even across the void, connections persist. The vast emptiness is punctuated by the distant glow of stars, nebulae, and subtle interstellar structures, a gentle reminder that space is full of motion and history, even where nothing appears to be happening. Reflection at this stage is inevitable. The scale of the journey encourages contemplation of time, distance, and the interconnectedness of cosmic processes. We are passing through a medium that has witnessed the birth and death of stars, the movement of galaxies, and the slow evolution of matter across millions of years. Even in the quiet, there is evidence of cosmic events, energy passing silently through the void, carrying with it the subtle signatures of forces beyond direct perception. From this midpoint, the perspective of Earth is instructive. The planet, once central in our night sky, is now nearly invisible, a distant point of light that represents home, origin, and the starting point of all exploration. Proxima Centauri, still far ahead, offers a focus, a destination, and a gentle red glow that contrasts with the blackness of the void. The journey itself becomes a meditation on scale. Distances measured in light years, time passing differently depending on perspective, and the vast emptiness filled with subtle processes that connect star to star, system to system, across the Milky Way. At the halfway point, the passage through interstellar space is uninterrupted, continuous, and serene. The faint light of distant nebulae, the gentle drift of interstellar dust, and the quiet passage of cosmic rays create a subtle backdrop for reflection. This is a moment to pause in the journey, to appreciate the immensity of the galaxy, and to consider the journey ahead. The midpoint is both a marker and a meditation, a quiet observation of the vastness between home and the nearest star, a reminder of the continuity of space, and an invitation to reflect on the cosmos at large. Even in this emptiness, there is beauty. Patterns emerge in the faint starlight, subtle shifts occur in the background glow, and the mind can perceive the coherence of the galaxy. Gravity has shaped these stars, magnetic fields guide the motion of particles, and light travels unimpeded across the void. Interstellar space is not barren. It is a living record of processes that span millions of years. The midpoint allows us to witness this quiet activity while remaining suspended between origin and destination, between the past light of Earth and the future light of Proxima Centauri. The midpoint is also a reminder of the persistence of observation. Every photon that reaches us has traveled across space for years, each carrying information about its source. The journey through this region is as much about understanding and reflection as it is about motion. The stars, the dust, the cosmic rays, and the interstellar medium all tell a story of the galaxy, of forces, events, and interactions that have shaped it over billions of years. In this quiet, uninterrupted passage, we gain a new perspective on the scale of the cosmos, the unity of its structures, and the nature of travel across vast distances. As we continue our journey beyond the midpoint, the vast emptiness of interstellar space gradually begins to yield subtle signs of our approaching destination. Proxima Centauri, the faint red dwarf star that has been a distant point of light on the horizon for years, begins to grow ever so slightly brighter. At first, the change is imperceptible, a barely noticeable glow against the tapestry of more distant stars, but with each passing light year, its presence becomes more defined. We are now roughly 3.5 light years from Earth, leaving just 0.74 light years to Proxima Centauri, and on Earth, over 3.5 years have quietly elapsed as our journey continues at the speed of light. Proxima Centauri is a small, cool red dwarf, far dimmer than the Sun, with a surface temperature of approximately 3050 Kelvin. Its red hue dominates its subtle light, giving it a soft, persistent glow that is calming against the surrounding darkness. Unlike the bright, familiar Sun, Proxima's energy output is modest, yet it carries profound significance. It is the nearest star beyond our Sun, part of the Alpha Centauri triple system, and it hosts at least one known planet, Proxima b, which orbits within the star's habitable zone. Observing this red dwarf from light years away, we begin to appreciate its quiet intensity, its potential, and its place as a beacon in the cosmic darkness. From this distance, Proxima Centauri's light is faint, yet its significance grows with proximity. We begin to notice subtle variations in brightness, hints of stellar activity that ripple across its surface. Red dwarfs are known for occasional flares, sudden bursts of energy that can increase their brightness dramatically for brief periods. Even from afar, the implications of such activity are clear. Planets orbiting such stars may experience dramatic changes in radiation, magnetic fields, and atmospheric conditions. The star is small, quiet for the most part, yet alive with the dynamic processes that characterize all stars. As we approach, the emptiness of interstellar space feels less uniform. Subtle clouds of hydrogen and helium drift across our path, remnants of long-ago supernovae and star formation events. Tiny dust particles scatter the faint starlight, creating soft glows and subtle gradients across the darkness. Cosmic rays continue to pass relentlessly, high-energy messengers from distant parts of the galaxy. Even in this quiet environment, the subtle interactions of matter and energy are present, a reminder that space, though vast and seemingly empty, is not truly inert. Distance becomes an increasingly tangible measure. From this point, traveling at light speed, we have covered over 80% of the journey to Proxima Centauri. The remaining 0.74 light-years corresponds to approximately 9 months passing on Earth, yet the journey feels continuous and meditative. The perspective of motion shifts. The stars around us appear slightly more fixed. The subtle parallax of Proxima Centauri against the distant background begins to emerge, and the faint red glow grows incrementally brighter with every passing moment. This is the first stage of intimate proximity, where a star that once seemed impossibly distant now begins to assert its presence in the field of view. The interstellar medium at this stage is a quiet companion. Fine hydrogen gas, tenuous but present, drifts slowly relative to our trajectory. Dust grains, too small to see individually, scatter faint light from more distant stars, creating subtle glimmers in the void. Galactic magnetic fields thread through this medium, guiding the motion of charged particles. All of these phenomena, though almost imperceptible to the senses, are active, dynamic, and continuous. Observing them requires patience, reflection, and a willingness to perceive the subtle rhythms of the galaxy itself. Proxima Centauri's light is a constant guide. Unlike the Sun, which dominates its local neighborhood, Proxima is small, modest, and quiet. Its luminosity is only about 0.0017 times that of the Sun, yet in its red glow lies a vast amount of energy, just enough to sustain conditions on Proxima b that could permit liquid water. The star's relative calm is deceptive, for red dwarfs are capable of producing violent flares, bursts of radiation that can alter planetary environments dramatically. Observing the star from a distance allows a perspective on both its steady presence and its potential for sudden activity, a duality that is characteristic of many red dwarfs throughout the galaxy. As we glide closer, the faint influence of Proxima's gravitational field begins to register. At this distance, the pull is subtle, nearly imperceptible, yet it sets the stage for the complex dance of orbits within the Alpha Centauri system. Proxima Centauri orbits the barycenter of its stellar system with its companions, Alpha Centauri A and B, over thousands of years. This motion is subtle from our approach, but it emphasizes that even seemingly solitary stars exist within networks of gravitational interactions, bound by the invisible threads of mass and motion. The journey at this stage also allows reflection on the continuity of cosmic time. The photons we observe from Proxima Centauri began their journey over 4 years ago, leaving the star before we ever began our voyage. Every speck of light from distant stars is a message from the past, a connection across time and space. As we move closer, the light becomes fresher, more immediate, yet still carries the memory of the star's history, the flares, magnetic activity, and subtle luminosity variations that occurred long before we began our journey. Interstellar space near our destination is quiet but filled with subtle structures. Tiny clouds of gas, remnants of distant supernovae, drift slowly in the gravitational field of the galaxy. Cosmic rays, having traveled immense distances, continue to bombard the region, evidence of energetic events from stars far beyond Proxima Centauri. The emptiness is profound, yet not truly empty. It is a canvas on which the history of the galaxy is painted, a medium through which energy, matter, and light continue their slow dance across vast distances. At 0.5 light-years from Proxima Centauri, approximately 4¼ years have passed on Earth, and the star's red light begins to dominate the field of view. The glow is faint but unmistakable, a soft presence against the blackness. We begin to notice subtle differences in color and intensity, hints of chromospheric activity and magnetic interactions that shape the star's surface. Observing these features from a distance allows a perspective impossible to achieve from Earth. The star is an object in space, with its own environment, history, and dynamics, separate yet intimately connected to the cosmos around it. As we move steadily closer, the interstellar medium continues to provide gentle context. Dust grains, though sparse, scatter the red light from Proxima, creating delicate glows and halos in the otherwise dark void. Hydrogen and helium drift silently, remnants of stellar processes that occurred millions of years ago. Cosmic rays, arriving from distant parts of the galaxy, continue their ceaseless passage. Each element reminds us that even in the vast emptiness of space, there is structure, interaction, and subtle energy, a quiet reminder of the dynamic processes that govern the galaxy. The midpoint of the approach is now a distant memory. Proxima Centauri is no longer a faint point among countless others. It is becoming a distinct object in the field of view. The red dwarf's glow, though soft, is unmistakable, a signal of both distance traveled and the immense emptiness we have crossed. Traveling at light speed, each fraction of a light year corresponds to months passing on Earth. Yet the continuous glide allows a meditative pace, a slow contemplation of the scale, the history, and the profound significance of reaching the nearest star beyond our Sun. Reflection deepens as the distance diminishes. The journey from the solar system, through interstellar space, past the midpoint, and now approaching our destination, is a meditation on scale, motion, and the continuity of the universe. Each light year carries a year of Earth's time, yet for us, traveling at light speed, the motion is smooth, continuous, and almost imperceptible. The emptiness is profound, yet filled with subtle signals of matter, energy, and light that connect star to star across the galaxy. By the time we reach 25 light years from Proxima Centauri, over 4 years and 3 months have passed on Earth, and the red dwarf's presence is commanding. Its color, brightness, and subtle variations are now observable with clarity. We can anticipate the gravitational pull it will exert on nearby objects, the potential for flares, and the orbit of Proxima b within the habitable zone. The star is no longer distant in any meaningful sense. It is a tangible presence, a quiet, persistent beacon that signals the nearing end of a long journey across the void. As we draw near, the red glow of Proxima Centauri strengthens, no longer a faint speck among distant stars but a distinct, tangible presence in the darkness. At this final stage of our journey, we are approximately 0.05 light years from the star, roughly 300 billion kilometers, and on Earth, just over 4 years and 3 months have passed since our departure at light speed. The long emptiness of interstellar space behind us emphasizes the significance of this approach. We have traversed the void, crossed immense distances, and now stand on the threshold of another star system, an entirely new celestial neighborhood. Proxima Centauri is a small, cool red dwarf with a radius about 1/7 that of the Sun. Its surface temperature hovers around 3050 Kelvin, giving it the characteristic deep red hue. Though its light is dim compared to the Sun, it is steady and persistent, carrying with it energy sufficient to influence its planetary system in subtle yet profound ways. Observing the star from this proximity, we notice slight variations in brightness caused by magnetic activity on the surface, flares, and star spots, all common features of red dwarfs. This intimate perspective allows us to understand its dynamics as a living, active star, not simply a distant point of light. The journey has also provided a perspective on the scale and structure of our galaxy. As we approach Proxima Centauri, the relative positions of nearby stars become meaningful. Alpha Centauri A and B, the larger companions in the triple system, can be observed faintly in the distance, tracing their long, elliptical orbits over millennia. The gravitational interactions among these 3 stars subtly shape the region, influencing orbits, potential debris, and even the paths of distant interstellar travelers. From our vantage point, we can observe this system as a coherent entity, a dynamic microcosm of stellar mechanics within the broader galaxy. Now, our attention turns to Proxima b, the planet orbiting within the star's habitable zone. Its proximity to the red dwarf, about 7.5 million kilometers, means that a year on Proxima b is only 11 Earth days, a rapid revolution around its host star. The planet's potential for liquid water has made it an object of intense interest in scientific observation. Though its surface conditions are shaped by the star's radiation and possible flares, it is a tantalizing possibility for habitability, a world illuminated by the quiet red glow of its small, persistent star. From this distance, we can only infer its conditions through careful observation of light curves, spectral analysis, and modeling of its atmosphere and potential surface features. The interstellar medium leading up to Proxima Centauri thins as we approach, yet subtle clouds of gas and dust persist. These remnants of ancient stellar processes scatter the star's red light, creating delicate halos and soft gradients in the surrounding darkness. Cosmic rays continue their passage, high-energy particles moving unimpeded through the void, evidence of distant supernovae and galactic events. Even in this quiet neighborhood, the forces of the galaxy are at work. Gravity shapes motion, light traces history, and matter continues its slow, continuous evolution. As we glide closer, the red dwarf's gravitational pull becomes noticeable. Though small compared to the Sun, Proxima's mass is sufficient to dominate the orbital dynamics of its planetary system. The planet, Proxima b, traces a tight orbit within the habitable zone, while any potential smaller moons or debris are subtly influenced by the star's gravity. Observing this from a distance, we perceive the delicate interplay of forces that shape planetary orbits, stabilize rotations, and maintain equilibrium in this distant system. The journey at light speed has now brought us almost entirely to the destination. From Earth, over 4 years and 4 months have passed, yet for us, the motion has been continuous, smooth, and almost timeless. The perspective gained is both humbling and awe-inspiring. The faint blue dot of Earth, once home, is now a distant memory, while the red glow of Proxima Centauri dominates the view, offering the first intimate look at a star other than our own. Proxima Centauri's light, though soft, illuminates the surrounding interstellar environment. Subtle variations in intensity hint at magnetic activity and flares, while the surrounding darkness reveals faint dust clouds and interstellar gas. Even in its modest glow, the star has shaped its region over millions of years, influencing the formation of planets, the paths of debris, and the distribution of energy in the system. Observing it now, we gain insight into the quiet power of red dwarfs and the complexity of even the smallest stars in the galaxy. Proxima b, illuminated by its host star, offers a unique contrast. Its potential surface conditions, climate patterns, and possible liquid water make it a prime candidate for study. Though we cannot see fine details at this distance, the planet's existence confirms that stars, no matter how small, can host worlds that may harbor the conditions necessary for life. This juxtaposition of star and planet provides a glimpse into the potential diversity of exoplanetary systems throughout the Milky Way. The final approach emphasizes the quiet majesty of space. The vast distances traveled, the immense emptiness of interstellar space, and the subtle, persistent signals of matter and energy all coalesce into a profound sense of scale. Time, motion, and distance converge as we reach our destination, the nearest star beyond our Sun, and its accompanying planet, Proxima b. The journey, once measured in light years, months, and years, now culminates in a tangible presence, a destination both real and symbolic, bridging the void between the familiar and the unknown. Reflection on the journey highlights the perspective gained, from Earth, across the solar system, past the heliopause, through interstellar space, and finally to the proximity of another star. Distances that once seemed incomprehensible are now tangible. Time, measured on Earth, has quietly passed, while our journey at light speed has maintained a meditative continuity. The stars, once distant points, now hold context, scale, and significance. The emptiness of space, once daunting, now frames the arrival at a new celestial neighborhood, a reminder of both the immensity of the universe and the human capacity for exploration and understanding. The glow of Proxima Centauri dominates the field of view, while Proxima b orbits quietly within the habitable zone. The distant companions, Alpha Centauri A and B, form a faint backdrop, illustrating the subtle gravitational dynamics of the triple star system. Beyond these, the galaxy stretches infinitely, dotted with billions of other stars, nebulae, and cosmic structures. We have traversed one of the shortest interstellar distances, yet even this journey emphasizes the vastness, complexity, and beauty of the Milky Way. At last, the arrival is both scientific and philosophical. We observe, reflect, and absorb the scale of the universe, the quiet dynamics of stellar systems, and the potential for life beyond our solar system. Proxima Centauri, a modest red dwarf, stands as a beacon, a reminder that even the smallest stars hold significance, influence, and wonder. The planet Proxima b offers a glimpse of possibility, a destination for contemplation, study, and the imagination. The journey has been long, measured in light years and Earth years, but the experience is timeless, a meditation on scale, motion, and the beauty of the cosmos. Having reached the vicinity of Proxima Centauri, we pause to observe and reflect upon the entirety of our journey, the distances traveled, and the profound insights that emerge from moving through space on a scale few have imagined. From the small blue dot of Earth to the faint red glow of the nearest star beyond our Sun, the journey illustrates both the immensity of the cosmos and the delicate precision of human understanding. It is a journey that combines distance, time, motion, and discovery, all unfolding in quiet contemplation. As we reflect, it is remarkable to consider the scale of what we have traversed. The distance from Earth to Proxima Centauri is approximately 4.24 light-years, or nearly 40 trillion kilometers. For an observer remaining on Earth, over 4 years have passed at light speed, yet for us, gliding through the void, the journey has been continuous, smooth, and meditative. The solar system, once so vast and familiar, is now a memory, its planets and moons diminished in the rearview of the journey, yet providing essential lessons in orbital mechanics, planetary formation, and the diversity of celestial environments. Observing the planets along the way, Earth's orbit, the Moon, Mars, Jupiter, Saturn, Uranus, and Neptune, provides insight into the mechanisms that govern planetary systems. From the Moon's cratered surface and subtle regolith to the vast storms and cloud belts of Jupiter, each object has revealed fundamental truths about physics, gravity, and atmospheric dynamics. The Voyager spacecraft, traversing beyond the heliopause decades before, demonstrated the persistence of human curiosity, providing data on magnetic fields, cosmic rays, and interstellar plasma that continue to inform our understanding. In interstellar space, we observed a medium that is not empty, but filled with fine hydrogen and helium gas, cosmic dust, and high-energy cosmic rays. These particles, remnants of distant supernovae and stellar processes, are subtle indicators of galactic activity. Their presence highlights the interconnectedness of the galaxy. Stars are born, live, and die, leaving traces that traverse light years and contribute to the cycle of cosmic evolution. Even in what appears to be emptiness, there is structure, motion, and evidence of processes spanning millions and billions of years. As we approached Proxima Centauri, we saw the first intimate glimpse of a red dwarf star, modest in size and luminosity yet dynamic in nature. Its surface is marked by magnetic activity, star spots, and occasional flares, reminding us that even small stars are alive with energy. Proxima b, the planet within its habitable zone, offers a compelling example of the diversity of exoplanetary systems. Though orbiting closely, with a year lasting only 11 Earth days, it may host conditions suitable for liquid water, demonstrating the potential for life even around stars much smaller than our own. The discovery of this planet in 2016 by astronomers using the radial velocity method represents a significant milestone in the search for habitable worlds beyond the solar system. Throughout this journey, several key discoveries in astronomy and astrophysics underscore the depth of human knowledge. The cosmic microwave background radiation, first detected in 1965 by Arno Penzias and Robert Wilson, offers a remnant echo of the Big Bang, providing insight into the origin of the universe itself. Observations of pulsars, rotating neutron stars emitting precise beams of radio waves, reveal extreme conditions in matter, gravity, and magnetic fields. The study of exoplanets, beginning in the 1990s and accelerating with missions like Kepler and TESS, has expanded our understanding of planetary systems, showing that planets are common, diverse, and often in configurations far different from our own solar system. Gamma-ray bursts, the most energetic explosions in the universe, provide insight into the life cycles of massive stars and the formation of black holes. Observations of black holes, both stellar mass and supermassive, illustrate the incredible warping of spacetime predicted by general relativity. Recent imaging of the event horizon of the supermassive black hole in M87 by the Event Horizon Telescope in 2019 brought a direct view of one of the most enigmatic objects in the cosmos, confirming decades of theoretical prediction. These discoveries, though distant, inform our perspective as we traverse interstellar space, providing context for the forces, structures, and phenomena we encounter. Reflection on these discoveries underscores a profound truth. The universe is both immense and intelligible. Patterns exist within the seeming randomness of space. Laws of physics govern the formation of stars, the motion of planets, and the propagation of light and radiation. Our journey to Proxima Centauri, while hypothetical at light speed, mirrors humanity's quest to understand these patterns. Each observation, from the orbits of Jupiter's moons to the faint glow of interstellar dust, connects to broader principles, linking local phenomena to galactic processes. At the midpoint of this reflective meditation, we are struck by the subtle beauty of interstellar space. The emptiness, vast yet filled with energy, offers an unparalleled perspective on scale and time. Cosmic rays trace the history of ancient explosions. Dust particles drift silently across light years, and faint nebulae hint at future star formation. Even the spaces between stars are structured, patterned, and alive in ways imperceptible to casual observation but fundamental to the mechanics of the galaxy. The quiet of space becomes a companion, a gentle backdrop for contemplation, encouraging awareness of both minuteness and grandeur. Proxima Centauri itself offers lessons in resilience and persistence. A small red dwarf, it burns steadily for tens of billions of years, far longer than the Sun will endure. Its ability to maintain fusion at a slow, steady pace exemplifies the diversity of stellar lifetimes and energies. Proxima b, despite its proximity to the star and potential exposure to flares, represents the possibility of habitability in environments vastly different from Earth. This juxtaposition of star and planet emphasizes the creativity of cosmic evolution, the subtle orchestration of forces, and the resilience of systems across unimaginable distances. From a broader perspective, the journey highlights the interconnectedness of human discovery and cosmic observation. The Voyager spacecraft, the Hubble Space Telescope, the Kepler mission, and countless ground-based observatories all contribute to a shared understanding, allowing us to perceive stars and planets light years away. Observations of the cosmic microwave background, pulsars, exoplanets, black holes, and supernovae reveal both the dynamics of the universe and the depth of human curiosity. Each discovery enriches the narrative of our journey, offering context and insight into the processes we have witnessed firsthand. As we reflect on the journey as a whole, from Earth, past the Moon and planets, through the heliopause, interstellar space, and the approach to Proxima Centauri, we gain a profound sense of perspective. Distances once incomprehensible are now understood as measurable, traversable in theory at light speed. Time, once linear and local, now stretches across years and light years, linking origin and destination in a seamless continuum. The emptiness of space, so vast and seemingly desolate, is a medium of energy, history, and motion. a reminder that even the quietest regions of the galaxy are alive with subtle activity. The journey concludes not with arrival alone, but with reflection on scale, discovery, and connection. From the faint blue dot of Earth to the red glow of Proxima Centauri, from the planets of the solar system to the interstellar medium, from cosmic rays to distant nebulae, the universe unfolds as a tapestry of beauty, structure, and meaning. The discoveries we have made, both observational and theoretical, serve as guides and companions, illuminating the path, explaining the processes, and revealing the elegance of cosmic order. Finally, in this reflective state, we consider humanity's place in the cosmos. Our journey to Proxima Centauri is symbolic, representing curiosity, exploration, and the desire to understand. The discoveries of cosmic microwave background radiation, exoplanets, black holes, and pulsars remind us of both the scale of the universe and the depth of human ingenuity. Space is vast, time is long, and yet observation, measurement, and reflection allow us to connect the dots, to trace threads across light years, and to find meaning in the quiet grandeur of the universe. As the red glow of Proxima Centauri illuminates its planet, we drift in quiet contemplation, reflecting on the journey and the discoveries along the way. The universe, immense and intricate, reveals itself gently, patiently, and continuously. Each star, planet, and particle is a note in a vast, ongoing symphony, a quiet melody that resonates across space and time. Our journey concludes with awareness, gratitude, and the serene understanding of the interconnected cosmos, a final meditation on scale, motion, and the enduring wonder of discovery. The starting point of our journey, Earth, the small, vibrant blue planet orbiting a modest star in a spiral arm of the Milky Way galaxy. From this perspective, the planet is a quiet jewel suspended in the vastness of space, a cradle of life, thought, and imagination. Its oceans ripple softly under sunlight, its atmosphere shifts with clouds, winds, and weather, and its surface hosts life in countless forms. Even though we have traveled across light years of emptiness, Earth remains our point of origin, a reminder of home and the conditions that made this journey of curiosity and discovery possible. As we left Earth, passing through the familiar orbit and glancing at the Moon, we experienced the first sense of cosmic scale. The Moon, a quiet companion that has witnessed millennia of change, revolved in its gentle orbit, cratered and serene. Its surface, etched with history, offered a glimpse of processes that unfold slowly and persistently over time. Craters that formed millions of years ago still mark the lunar surface, reminding us that even in apparent stillness, events leave their traces. The Moon's silent presence, reflecting the sunlight, guided our thoughts as we ventured outward, beyond the familiar gravitational embrace of our home planet. Continuing beyond the Moon, we observed the planets of our solar system in all their variety. Mars, with its red surface and evidence of ancient water, spoke of geological history, of erosion, volcanism, and the slow sculpting of landscapes over eons. Jupiter, the largest planet in our system, displayed swirling clouds, massive storms, and a magnetic field that dominated its neighborhood. Saturn's graceful rings, delicate yet immense, drifted silently, particles tracing paths under the influence of gravity and the occasional shepherd moon. Uranus and Neptune, distant and cold, glowed faintly in the dim sunlight, their blue-green hues caused by methane absorbing red light, reminding us of the diversity of planetary atmospheres and the subtleties of color and chemistry in distant worlds. These initial steps through the solar system prepared us for the vast, quiet stretch of interstellar space. Beyond the heliopause, we entered a region almost devoid of familiar landmarks. Here, the sun became a distant point of light, and the emptiness stretched outward in every direction, punctuated only by faint stars, wisps of interstellar gas, and cosmic rays traveling through the void. The interstellar medium, though thin and tenuous, contains hydrogen, helium, and dust, remnants of long-dead stars and the seeds of new ones. Even in this apparent emptiness, the forces of the galaxy were at work, quietly shaping, moving, and evolving across light years of distance. As we traveled deeper into the void, time took on a new dimension. At the speed of light, every light year of distance corresponded to a year passing on Earth. This perspective encouraged reflection. What was a moment on Earth stretched into a vast, contemplative expanse of observation and thought. We watched the distant stars, each a sun in its own right, their light traveling years, decades, or even centuries to reach us. Some stars, long gone, continued to send their photons across space, reminders that the universe preserves memory in subtle, elegant ways. At the midpoint of our journey, when we were equidistant from Earth and Proxima Centauri, we paused in quiet meditation on scale and motion. Here, the emptiness of space becomes almost tangible, yet it is filled with unseen energy, gentle drifts of interstellar dust, and the faint glow of hydrogen clouds. Cosmic rays traverse this expanse, evidence of ancient supernovae and energetic galactic processes. Even in silence, the universe speaks, if one listens slowly and patiently, attuning to the subtle rhythms of motion, light, and energy that continue unceasingly across the void. As Proxima Centauri drew nearer, its red glow became increasingly prominent, soft and steady, yet alive with subtle flares and magnetic activity. This small star, modest in energy output compared to the Sun, has endured for billions of years and will continue to burn quietly for tens of billions more. Its red light, visible even from light years away, is a gentle beacon in the darkness, marking the location of a star that hosts its own worlds, including the intriguing Proxima b. This planet, orbiting within the star's habitable zone, represents the possibility of conditions suitable for life, a reminder that even the smallest stars can harbor wonder and potential. The approach to Proxima Centauri allows a deep appreciation of the interconnectedness of cosmic phenomena. Gravitational forces, magnetic fields, and stellar radiation all interact subtly yet profoundly, shaping orbits, atmospheres, and the movement of matter. Observing Proxima b in its tight orbit offers insights into the dynamics of exoplanetary systems, emphasizing that even distant worlds are subject to the laws of physics we have come to understand here on Earth. The interplay of star and planet, though gentle and slow, reflects the continuity of natural law across the galaxy. During the final approach, as the distance diminished to mere fractions of a light year, the journey became an opportunity for reflection. Every object observed, every particle of dust, every photon of light carries information, history, and a story. The vast emptiness is not barren. It is a medium of subtle energy, structure, and memory. This understanding, absorbed slowly and continuously, encourages a gentle contemplation of the universe's scale, its rhythms, and the interconnectedness of all phenomena, from the smallest particle to the largest star. We can now consider the discoveries and observations that have shaped our understanding. The cosmic microwave background, a remnant of the early universe, informs us of origins, of the Big Bang that seeded space with energy and matter. Pulsars, rotating neutron stars emitting precise beams of radiation, reveal the extremes of physics, gravity, and magnetism. Black holes, both stellar and supermassive, illustrate the profound warping of space and time, while gamma-ray bursts demonstrate the immense energy released in cataclysmic stellar events. Each discovery is a note in the symphony of the cosmos, evidence that even the most violent or distant phenomena follow patterns that can be observed, measured, and understood. The journey also illuminates the subtle beauty of interstellar processes. Hydrogen clouds drift slowly, tracing the skeletons of past star formation. Fine dust particles scatter distant light, creating soft halos and gentle glows. Cosmic rays, imperceptible to the senses, reveal the history of energetic events across the galaxy. Even in what feels like emptiness, the universe is active, alive in a quiet, persistent way that can be appreciated fully only from a patient, reflective perspective. As we settle into this reflection, we sense the continuity of time. Light years, once abstract, now carry meaning. Each year passed on Earth corresponds to a journey across the void. Stars we observe are witnesses to epochs long past, and yet their presence is immediate in our perception, connecting past and present. The journey from Earth to Proxima Centauri becomes not simply a travel through space, but a meditation on the nature of time itself, a slow awareness of the flow of history, energy, and light across incomprehensible distances. We are also reminded of the fragility and resilience of life. On Earth, life thrives within a delicate balance of conditions: distance from the sun, atmospheric composition, magnetic protection, and the presence of water. Proxima b, though vastly different, represents a similar balance on another scale, a distant possibility of habitability shaped by gravity, radiation, and atmospheric potential. Observing this planet from nearby reinforces a sense of wonder and respect for the delicate interplay of forces that make life possible. The journey encourages mindfulness and calm. The gentle motion through space, the slow accumulation of distance, and the quiet beauty of stars, dust, and cosmic rays create a rhythm, a meditative cadence. With each passing moment, the mind can settle, breathing in the quiet majesty of the cosmos. Thoughts drift slowly, like particles in interstellar dust, and attention expands to encompass vast distances, subtle energy flows, and the serene continuity of natural law. We can now visualize the galaxy from a cosmic vantage. The spiral arms of the Milky Way stretch across the sky, stars clustered in regions of formation, nebulae glowing softly, and voids between structures offering contrast and depth. Galactic rotation moves slowly, imperceptibly over millennia, yet measurable across time. Each star, each planet, each cloud of dust contributes to the dynamic, continuous dance of the galaxy. Observing this from the quiet vicinity of Proxima Centauri allows a gentle awareness of scale, motion, and interconnection. The red glow of Proxima Centauri continues to dominate the nearby space, yet its light is soft and non-intrusive. This quiet persistence mirrors the rhythm of the universe, steady, patient, and continuous. The planet Proxima b orbits in its tight ellipse, a small world illuminated by a gentle star, quietly tracing its path. The combination of star, planet, and surrounding interstellar environment forms a tableau of subtle motion, quiet energy, and calm, meditative observation. As we dwell in this state, we can reflect on human achievement and curiosity. Observations made from Earth, by telescopes, spacecraft, and scientific instruments, have allowed this journey to be imagined, measured, and understood. From the Voyager spacecraft exploring the outer planets and interstellar medium, to the Kepler and TESS missions discovering thousands of exoplanets, to the Event Horizon telescope capturing the silhouette of a distant black hole, humanity's gaze has expanded ever outward. Each observation contributes to a larger understanding of the universe, connecting distant phenomena to human comprehension. In this quiet contemplation, the mind can rest. The journey from Earth to Proxima Centauri becomes a gentle metaphor for exploration, patience, and reflection. The distances traveled, the vast emptiness crossed, and the proximity of a new star system highlight the grandeur of the cosmos, while simultaneously emphasizing the small, serene point of observation from which we contemplate it. Every detail, from interstellar dust to cosmic rays to distant nebulae, invites slow, deliberate attention, encouraging calm awareness and a meditative state. The final moments of this reflection are devoted to stillness. Time, distance, and light converge. The quiet red glow of Proxima Centauri, the orbit of Proxima b, the gentle drift of interstellar dust, and the subtle traces of cosmic rays combine into a soft, rhythmic presence. The universe, vast and incomprehensible in scale, is also intimate, accessible in thought, perception, and reflection. Each observation encourages a slow breath, a gentle release of tension, and a profound awareness of connection. Even as the journey concludes, the mind remains suspended in contemplation. Earth, a distant blue dot, continues its orbit, spinning quietly in the warmth of the sun. Proxima Centauri, a nearby red dwarf, burns steadily, illuminating its planet. Between them lies the space we have traversed, empty yet filled with subtle energy, history, and cosmic memory. This reflection, unhurried and continuous, allows the mind to drift in rhythm with the universe, experiencing both scale and serenity. As we settle fully into this meditative state, the journey through space becomes a lullaby. Distances, times, and energies fade into gentle awareness. Stars twinkle softly in the distance. Cosmic rays and dust drift endlessly. Planets orbit quietly. The mind, attuned to these rhythms, slows its own pace, synchronizing with the quiet cadence of the galaxy. Thoughts drift without effort, observation becomes contemplation, and awareness expands without strain. With each breath, the mind travels effortlessly across light years, moving gently between Earth, the solar system, interstellar space, and Proxima Centauri. The quietude of space, the soft glow of stars, the subtle motion of particles, and the continuity of natural law guide the listener into a state of rest. The journey, both literal and reflective, now becomes a meditation on the immensity and gentleness of the cosmos. In these final moments, the listener is encouraged to release tension, imagine drifting through the soft, quiet expanse of interstellar space, and allow the rhythmic patterns of light, energy, and motion to lull the mind into rest. Each star, planet, and particle is a note in a gentle symphony, a cosmic lullaby that resonates across time and distance. Proxima Centauri glows softly in the distance, Proxima b traces its orbit, and the universe continues its slow, deliberate motion. And so, with awareness of scale, motion, discovery, and quiet reflection, the mind drifts. Earth, Proxima Centauri, and the vast expanse in between become a gentle continuum. The hum of the galaxy, the flow of cosmic rays, the orbit of planets, and the glow of distant stars provide a soft rhythm, a serene backdrop against which sleep can arrive gently, naturally, and fully. Drifting softly through the darkness to our nearest stellar neighbor, one begins to realize that Alpha Centauri is far more than just a point of light. This system is rich with complexity, history, and mystery, a tapestry woven from 3 stars in gravitational dance, whispering of worlds both seen and unseen. It is the closest star system to us, but also among the most surprising, a place where our notions of planetary architecture, star formation, and cosmic evolution are both challenged and expanded. Alpha Centauri is composed of 3 stars bound together by gravity in a delicate, ancient embrace. The 2 brightest, often referred to simply as Alpha Centauri A and B, form a binary pair, 2 sun-like stars locked in a long, graceful orbit around each other. Their separation changes dramatically. Sometimes they draw near, at about 11 astronomical units, and at others, they drift to nearly 35 times that distance, tracing a vast ellipse that completes a cycle roughly every 80 years. Over time, that motion has been studied in exquisite detail, reminding us that even in stellar companionship, nothing remains static. Beyond this pair lies a 3rd star, Proxima Centauri, a red dwarf, dim in our sky but vital in the story of this system. Although much smaller and fainter than its siblings, Proxima is gravitationally bound in a slow, sweeping orbital dance that may take hundreds of thousands of years to complete, tracing a path that sometimes brings it relatively close, and at other times carries it far into the cold expanse. What makes this trio more than simply familiar neighbors is how different each member truly is. Alpha Centauri A is very much like our Sun, a G-type star, warm and bright, with a gentle, steady output of light and energy. Its partner, Alpha Centauri B, is somewhat cooler and smaller, a K-type star, with a softer glow and a quieter energy. Proxima, by contrast, is an M-type red dwarf, modest in size and output yet potent in its own quiet way. Despite the differences, These three are bound by gravity and history, and the shared journey offers a profound window into the variety that can exist even in a nearby star system. Recent observations have added entirely new layers to our understanding. Just in the past few years, scientists using the James Webb Space Telescope, JWST, have collected data that hint at a possible gas giant planet orbiting Alpha Centauri A using the MIRI instrument. Researchers placed a coronagraph over the blazing light of the star to search for faint companions. In August of 2024, a faint signal appeared, an object remarkably faint, perhaps more than 10,000 times dimmer than the star it orbits. Modeling suggests this candidate planet could have a mass similar to Saturn, traveling on an elliptical orbit that carries it between roughly 1 and 2 times the Earth-Sun distance. If this planet is real, its orbit lies within a region we might call the habitable zone, though as a gas giant it would not host life as we know it. What is astonishing is how this candidate planet seemed to vanish in follow-up observations in early 2025. Researchers simulated millions of possible orbits and found that in many scenarios, the object could pass close to the star, slipping into its glare and becoming temporarily invisible. That possibility, of an orbit that hides and reveals, is both humbling and thrilling, and it pushes the boundaries of how well we can observe worlds in such a bright, complicated system. Each new step in that research is a dance between light and shadow. The team had to subtract not just the light of Alpha Centauri A, but also that of B, whose brightness complicates observations. They built computer models, simulated orbits, and considered the gravitational interplay between the stars and this candidate planet. That they might have glimpsed a world so close to us is remarkable, but equally remarkable is their humility. The understanding that even with the JWST, some secrets of nearby stars require patience, repeated observation, and sophisticated modeling. In addition to that possible gas giant, Proxima Centauri itself hosts known worlds. Proxima b is perhaps the most celebrated, a planet roughly Earth mass orbiting very close to Proxima, taking only about 11 Earth days to complete one full revolution. That close orbit places it within the star's habitable zone, where temperatures could allow liquid water under certain conditions. Yet the story doesn't end there. Observations suggest there may exist Proxima c, a far more massive planet, more like a mini Neptune in size, circling at a much greater distance, taking years to complete its orbit. This world, if confirmed, would demonstrate the diversity of planets that can exist even around a modest red dwarf. Intriguingly, radio observations and imaging from other instruments have hinted at dust belts around Proxima, akin in some sense to our Kuiper belt, a cold disk of small bodies and drifting dust at tens of astronomical units, whispering of a dynamic and structured system beyond the immediate neighborhood of its star. Beyond planets, there is also the question of how Proxima became part of this system in the first place. Some researchers have explored whether Proxima was captured by the gravitational influence of Alpha Centauri A and B rather than forming in place. Simulations suggest that a large fraction of possible past orbits would have allowed Proxima to remain bound, while in other scenarios it might drift off entirely over cosmic timescales. There are even hints, though not yet conclusive, in the metallicity of the stars, subtle differences in their elemental compositions, that Proxima might have a different origin. This possibility, that Proxima was once a solitary wanderer captured into an orbit around two suns, opens up a poetic notion that even nearby star systems can grow through encounters, mergers, and galactic tides. Another fascinating aspect is the delicate habitat of potential Earth-like planets in this system. Some theoretical studies of planets orbiting Alpha Centauri b, the cooler of the two Sun-like stars, suggest that the presence of its companion, Alpha Centauri A, would cause subtle climate oscillations on any orbiting world. Because the binary companions tug gravitationally and affect each other's radiation, a planet around B could experience temperature swings of just a few degrees over long timescales depending on how its orbit and tilt align. These climate variations, modest as they may seem, hint at the rich complexity of habitability in binary systems. Life, if it ever arose, might adapt to slow cycles of warming and cooling, shaped by the binary dance overhead. There's also the question of dust, debris, and longer-term architecture. Observations by ALMA, the Atacama Large Millimeter, Submillimeter Array, have detected rings or belts of dust around Proxima Centauri, possibly ranging between 1 and 4 astronomical units, at temperatures as low as 40 Kelvin. These disks are reminiscent of the Kuiper belt in our solar system, regions populated by icy bodies and dust, and they could be the leftovers of a planet-forming process, or reservoirs of comets and minor bodies that trace the ancient history of this system. The total mass of that dust is estimated to be on the order of a small fraction of Earth's mass, but its very presence reveals that Proxima is not a barren star. It has structure, debris, and perhaps smaller bodies still waiting to be discovered. The stability of orbits within this system is not guaranteed but is deeply nuanced. The gravitational influence of two Sun-like stars means that stable planetary orbits are more challenging, but not impossible. Planets in some orbits may remain stable for eons, while others might be nudged by gravitational interactions into chaotic paths. This complexity ties into how planetary systems form. The presence of a close stellar companion shifts accretion disks, influences resonances, and can sculpt the orbits of forming worlds in ways that single star systems do not. Another layer of intrigue lies in the possibility of exomoons. If the candidate gas giant orbiting Alpha Centauri A is real, it might host one or more moons. While no moon has yet been detected, it's tempting to imagine that such a giant could harbor satellite worlds, perhaps rocky, perhaps icy, that might themselves be worthy of exploration. In speculative discussions, some have even drawn parallels to Pandora from science fiction, envisioning a moon in the habitable zone of a gas giant orbiting a nearby star, but such ideas remain speculative until more data arrives. Beyond the physical bodies, there is a philosophical and technological dimension. Because Alpha Centauri is so close, just over 4 light-years away, it has been a prime target for not just observation, but conceptual mission design. Engineers and futurists have proposed spacecraft that might one day reach this system, multi-generational vessels, fusion-driven ships, and even laser-driven probes. The very proximity means that in the future, if our technology permits, this is among the most likely destinations for humanity's first interstellar exploration, a dream carried by both science and imagination. The studies of this system also enrich our understanding of how common or rare systems like ours might be. If a gas giant can exist around one of the Sun-like stars in a tight binary, and if small rocky worlds can orbit a red dwarf in the same system, then planetary architectures might be more flexible and diverse than once believed. Alpha Centauri becomes a kind of laboratory. By studying its stars, disks, and candidate worlds, astronomers can test theories of planet formation, binary star dynamics, and long-term stability in ways that are difficult with more distant systems. On the more speculative front, the fact that Proxima orbits at a great distance, combined with the possible presence of dust belts, raises the question of comets, asteroids, and long-term reservoirs of small bodies that might occasionally be perturbed inward. Could there be comet showers in this system? Could small bodies carry water or organic materials across vast orbits, seeding the inner parts of the system? While such ideas remain speculative, they spark the imagination and emphasize that even our nearest neighbor may harbor subtle, dynamic processes. There is also the matter of stellar activity. Proxima Centauri is known to flare. This red dwarf periodically emits bursts of radiation, high-energy particles, and magnetic instability. Such flares can have profound implications for nearby planets, especially those in tight orbits like Proxima b. Any world there would need to endure radiation, charged particles, and stellar winds, which could strip atmospheres or drive complex chemical reactions. This adds attention to habitability. Being in the right zone for liquid water might not be enough. the star's temperament plays a critical role. Yet, even with that challenge, the concept of habitability in the Alpha Centauri system remains deeply compelling. If Proxima b has retained an atmosphere, or sheltered pockets of water, perhaps under magnetic or geological shielding, it might offer conditions for life very different from our own. Even if life as we know it is unlikely, the system remains a powerful symbol, a nearby example of how varied and resilient planetary environments can be under different stars. Beyond the scientific, there is the poetic. The idea that just a few light years away, in the whisper of cosmic dust in the glow of a red dwarf, there may lie worlds that have evolved in their own rhythm, shaped by the tug of three stars and the slow swirl of interstellar matter. The possibility of discovering a moon, a rocky planet, or even a ring of debris invites us to envision a future in which exploration, once limited to our solar neighborhood, reaches outward in both imagination and technology. Alpha Centauri challenges us not just to look outward, but to think differently. It reminds us that stellar systems are not uniform, that planets can form in unexpected places, that orbits can be shaped by complex gravitational interplay, and that the nearest stars may be more diverse and rich than we ever assumed. In its embrace of three stars, in its dust belts, candidate planets, and dynamic stability, it offers both a mirror and a contrast to our own solar system, a canvas on which nature experiments. For a listener drifting in thought, the Alpha Centauri system becomes a meditative space. Imagine the binary suns circling each other, the red dwarf companion drifting at vast distances, and unseen planets tracing silent orbits. Dust drifts on long, slow paths, illuminated faintly by starlight. Flares erupt, then fade. Moons, maybe, circle unseen giants. Over centuries, the gravitational dance continues, shaping worlds, sculpting space, whispering histories written in light. This is not just a neighboring star system, it is a story, unfolding in real time and deep time, a place where astronomy and imagination meet. In pondering its secrets, we touch the frontier of what we know and what we hope to know. As you close your eyes, you might picture yourself as a silent observer in that distant realm, drifting through the rings of dust around Proxima, or watching the slow orbital dance of Alpha Centauri A and B. The system remains both intimately close and profoundly mysterious, a reminder that even our deepest scientific endeavors leave room for wonder, speculation, and the gentle hum of cosmic possibility. The journey is complete, not in action alone, but in awareness. The vastness of the universe, the richness of discovery, the gentle rhythms of stars and planets, and the quiet passage of time combine to create a meditative state. Thoughts slow, breathing slows, attention drifts outward, yet remains calm. Space, vast and eternal, cradles the mind. Reflection fades into serenity, observation fades into gentle awareness. And in this quiet, gentle space, sleep arrives.